welcome back to another episode of Links Digital Online OpenCV tutorial, and today we'll be exploring another function in OpenCV, which is something that we will use to build up to our eventual object detection that we're going to do, and that will be known as the filtering. So today we'll just do a duplicate of our file that we used previously, and let's get started. So just a quick recap is to capture the video of using our web camera, and we'll be using this loop to look through, capture images of each frame, and then if successful, so this will return a true, and then we will print out the frame. Right, so let's get to it. So today we're going to add on to this. So the frame comes as a BGR format. Right, so the images in OpenCV comes in the BGR format. So unlike the normal RGB format, the array is different. So for an image, if you print out the pixel array, the RGB will look something like this. Say, I'm not sure what color this is, but it will look like this, which normally is RGB values. But for OpenCV, the images or the pixels come in B and G and R. So that's just a note. So in the future, when we do image processing, if we need to configure it in such a way that all three are in the conventional RGB format, we'll have to do it. Alright, so instead of the normal RGB format for each frame, the pixels come in the BGR format. So instead of RGB, OpenCV does it as Right, so if we want to do future image processing next time, we might have to take this into consideration to switch the array, each element of the array. Right, so for now, let's just KIV that and move on to the next part. So let's look at this, and next we will want to convert the image. So if we print out what we had from the previous session, like this. Yep, so it's just, it looks like this, like that, and then we close it. Right, so now we want to turn it to a grayscale image. So instead of having the RGB, or for this matter BGR format array of colors, we're gonna have it in grayscale. So it does, let's call this new frame gray frame, and then we will use OpenCV function called use. Right, so instead of having it in color, so we'll try to convert it into grayscale format. That will be very useful in future steps where we want to do image filtering, image processing. We usually would make the image a grayscale first. Right, so let's call the new frame gray frame, and we use CV2. So this will convert the colors of, it's a function within CV2 that will help to convert the image to anything we want. So we pass in the first variable, which is the frame that we want to work on, and then the second one will be a function called color GR to. So this will convert the initial image that we have to a grayscale image. So what we have to do is change this to gray frame. So it just corresponds to this variable over here. Frame, and let's run it. The colors. And we have our grayscale frame, right? So that's how it looks like over here. And close it. Right, so if we want to run multiple frames at the same time, all we can do is just copy this line, put it below, and frame this. And then we will get, just to do a comparison of the two frames that we're going to print. right? So we have one color and another grayscale. So that's how we do that. So let's press Q, 1Q to close the window. Alright, so now let's move on to the main part of what we're going to do today, which is the Canny image processing. Right, so the idea of Canny image detection will be ultimately to do lane detection in future, or to detect certain fixed key features of a certain picture or video that we're going to capture. So the idea is to reduce the noise, or so-called noise in the picture, and we will take a look at how it's going to be done like this. Right, so all we have to do is to add on this. So let's just remove this for now. Let's look at this, and we go to Canny frame. So we'll build on another filter from this. So it will look like this, and all we have to do is cv2.canny. We pass in the gray frame this time, and we set the minimum and maximum thresholds. Right, so this will mean how much so-called the maximum and minimum line detection you want to achieve from the image. So you can print it out over here. And we run it. Right, so you can kind of see the key features of the image over here. And if I turn around, just to know there's some very key features that you can observe that still remain detectable in the image. For example, the word over here. So, for example, if I take, let me just take objects, this over here, you kind of see that the lines are made out. So, those that are clearer disappear. So, if you look a bit further, you should be able to detect words. So, for example, the shirt I'm wearing, the word Nexus on it, and it appears really clearly. So this will be used for some of our functions that we want to do later that involves maybe figuring out certain words on the road. This is a very important feature that we can use. Right, so now let's take a look at how these two arguments that we pass in can affect the quality of the image or the output that we get. So let's make in another Canny frame, we call it Canny frame 2. So we're still similarly passing the same grayscale frame, but this time maybe we'll do it at, say, and let's go have a big range on this, 50, and then we will just print it below. So if we want to print two images again, so we can just do this. This is the second one, and we will add two. So this corresponds to this. Similarly, Canny frame to Canny frame, and let's see how it goes. Right. Wow. Okay. As you can see, all the very minute details are detected in Canny frame 2, and Canny frame 1 detects very few small lines. Okay. So that's how it works with this. And if we want to, so if you want to look for lane lines, or especially for words, that's what it's good for, we can actually have it at a higher detection. So if you want to detect smaller, finer details, you can have it at lower numbers. Look at it. Right, so it really detects the very, very fine, small lines for low values. And for high values, it will detect frame back. Right. That's the difference that we see. So that's the relevant thresholding has to be done if to receive a certain. So we have to do the correct amount of thresholding for the kind of frame that we want to achieve from this. So for what I would suggest would be, if you want to detect normal words or big images, just the outline or silhouettes of people, of items, of words, letters, alphabets. A range of 100 to 200 would be good with little noise. So things like, if you want to look at words, if you want to detect humans, people, this range would be good. So later on when we do our cascading of classifiers for humans, for certain alphabets, this is something that we will be looking at. Let's to close it, and that's about it. So we have explored the Canny image. So how about let's try not using the grayscale image, see what we get. Right, you can see that if we use the color image, we apply the Canny filter on the color image instead of a grayscale, we do see some small so-called noise in the background. And that's something that can be eliminated if we actually do a grayscale on the image. Right, let's just, for the sake of it, let's just do a comparison of frame color, frame to scale. So for this, we will apply, for the first Canny frame, we'll apply the Canny function on the original image, which is the color one. And for the second, we will do it on the gray frame. We'll keep the minimum and maximum thresholds the same. And frame 2 again, and so you can see, you compare the one with color and the one with grayscale. Definitely the one on the color, it looks similar, that's for sure. And even when you look at words, it's kind of the same, but definitely the one which we applied the grayscale filter to, you can see a better, more clear words. You can see the N-E. If I remove my headphones a bit, it looks really cleaner on the left. So that's what we can use to detect images or words faster, more precisely, more accurate. So let's just close this. Alright, so that's the end for today's session. And so next we'll be looking at how to put multiple frames into one window. So that will make comparing way easier, and also to reduce the size and resolution of each frame. Because currently, as of now, when we launch the module, our image, we can't scale it. It's a fixed size because this is the original frame camera. So later we'll be looking at how we can scale the image down so we can do a comparison of frames. And it'll be less choppy. See, if I move, it takes a while for the frame to actually move, but we'll look at how we can make it faster and do more real-time detection. Right, so that's it for today. See you next time.